Hey everybody, one last thing before we move on. I need to talk about alloys. Alloys, okay? Alloys are mixtures of metals. They're these hybrid metals we make in order to make different properties of metals, okay? It's how people made bronze back in the day, bronze shields, okay? Metals by themselves are usually typically pretty soft, okay? They don't do very well by themselves. Sometimes they do, but if we can mix them and give them nice properties of each metal, then we could form some really strong stuff like steel, bronze, and brass, and so on and so forth. So there's just two types of alloys we got to talk about. Let's talk about the first one, which is substitutional alloy. Okay, substitutional alloy. If you look at that word substitutional, we're going to be substituting something in. What is a substitutional alloy? We mix metal atoms of similar size to give them different properties. Okay? So, zinc on itself is kind of brittle. Okay? Copper by itself is really malleable, right? Copper wire, you can bend it back and forth. Zinc is hard, but it's really easy to break. So what they do is they'll go ahead and they'll take some copper. Don't write this down just yet because I'm about to change it, okay? They'll take copper. These are copper atoms if I were to zoom in on them. They'll take copper atoms, which again is very bendable, malleable. And what they'll do is they'll take a couple out and they'll throw some zinc in there, right? Zinc is right next to copper on the periodic table. So they got very similar size. So I could put in some zincs in here without really messing up the order of these atoms. And what happens is that you get a nice mix of both of those properties now, and you could form some brass, okay? Or I believe it's bronze. Bronze, I believe, is a mixture of zinc and copper, and then brass is a mixture of copper and tin, and I think one more metal. But I'm pretty sure this is bronze. Okay, so this is what they did in medieval times, right? They figured out that they can mix copper and zinc together and form these nice weapons and shields, okay? So this is a substitutional alloy. We're substituting in atoms of similar sizes in order to give them better properties. Let's talk about another alloy, which is a interstitial alloy. Interstitial alloy. Okay? Inter kind of sounds like into, okay? So we're going to be putting an atom into a metal atom to make it stronger. That's what interstitial alloy is. We put in smaller atoms. Let me rephrase this. We put smaller atoms into a metal to make it stronger. Okay? So this is where we're putting smaller atoms, we're packing them into metal atoms to make them stronger. And I'm going to draw a picture here, okay? Don't write this down yet because I'm going to be changing some things. So here I just have a bunch of iron. Okay, iron is actually really, really brittle. They used to make bathtubs out of iron. Some old houses still have iron bathtubs. Okay, they're really, really heavy. So just to get them out of the house, you just hit them with a hammer and they break right apart. Okay, that's why Iron Man is kind of a dumb name. Okay, because iron is really brittle. Iron Man should really be called Interstitial Alloy Man. Okay, now he's probably called Nanobot Man, but I digress. Anyway, to make this iron stronger, there's all these spaces in between here, okay? You could get some force in between those spaces and break apart those iron atoms. So what can we do to make this guy stronger? We could pack it full of smaller atoms, such as carbon, okay? So we could go ahead and we could pack these irons full of smaller atoms like carbon and make steel, okay? That's all steel is. It's just iron infused with some carbon, and now we make that really, really strong. Okay, we packed it full of those small atoms. Now if you try to break it, it's not going to happen, right? We have to heat it up a bunch in order to soften it, in order for it to bend. Okay, so that's interstitial alloys. We're putting smaller atoms into interstitial. Okay, one last thing I want to talk about, and that is metallic bonding. Metallic bonding. And science books love for you to know the definition of metallic bonding, okay? State standards across the nation want you to know the definition of metallic bonding. So here it is, all right? What is metallic bonding? It's just metal atoms surrounded by, and they love this term. No matter what chemistry book you look at, you'll see this term in every single one. Surrounded by a sea of electrons, okay? So that's what metallic bonding is. You got these metal atoms that have positive charges, so they should repel away from one another. But the only thing that keeps them from not repelling away from one another is these kind of cattle dog electrons that are keeping all these metal atoms together. So here's a picture, right? I'm going to have all this copper. I'll throw a copper 3+ in there as well, and a copper 1+, just because they can have varying charges. They should disperse away from one another. But there's something that keeps them all together, keeps them all corralled, and it's this sea of electrons they're talking about. Okay? That's what metallic bonding is. It's just these metal atoms surrounded by a sea of electrons. Okay, this is actually really, really nice. This gives metal some really awesome properties. In order for electricity to transfer, you need some electrons in there. And that's what's really nice about this. This electricity can transfer through those electrons. That's why copper wire is such a good conductor. Okay, it also kind of makes the bond not extremely strong. So if you want to heat up this metal a little bit, you could soften it up, no problem. Okay, and melt it and form it into other substances. Okay, so always remember, metallic bonding is just metal atoms surrounded by a sea of electrons. All right, know your substitutional alloys, know your interstitial alloys, know metallic bonding. Again, science books love that definition, so make sure you know that, and then have yourselves a great day.